So I've got a sideways parabola, which I've graphed in red, and a straight line in gray. And if I notice that I've got it's easier to think of horizontal as rectangles instead of vertical rectangles, because the vertical rectangles always have the top isn't always the red and the bottom isn't always the gray. So for example, in this area, it's the top and the bottom that are both red. So it's harder to think of the area integrated over the x variable. It's easier to think of them as horizontal ones because the red is always on the left and the gray is always on the right. So that's what we're going with. Now to find the intersection points, I'm going to solve for y instead of for x, since I know that I'm going to integrate in number one, it's easier to solve, and number two, we're integrating over the y variables. So I'm letting solved for x here and let these two equal here, this one and this one, and then moved my variables over, factored, and found two intersection points. So y equals 1, 3, and y equals negative 1, 3 and negative 1. So I know that my integration goes from negative 1 to 3, and it's the red, the parabola, we're not talking about top and bottom, we're talking about right and left. So this is the furthest right, it's the straight line, and the furthest left is the parabola. And remember, we're using the y variable, so everything has to be written in terms of y, and we're integrating with respect to y. So now it's just a straight up integration. I'm going to write it as one polynomial. Then I'm going to actually do the integration, which I'm going to move my window up a little bit there and increase all of my variables. So this increases by 1, this one increases to y squared, and that one to y cubed. And then I'm going to cancel the 2's here to simplify my expression before I plug in my 3 into all three terms, and then my negative 1 into all three terms. And my final answer is, just off the page here, 32/3.